The Sun recently entered a state of extreme agitation, marked by a weekend of chaotic activity that resulted in a dense jet of plasma and magnetic fields being shot into space, with the potential to affect Earth. Last Sunday, the first astronomical observatories recorded an impressive sequence of 26 solar flares, culminating in an event of frightening magnitude classified as X 8.1. This explosion was not just a common flare. It was an extremely violent phenomenon that ejected solar material at high speeds. Now, this cloud of charged particles and radiation is traveling through the solar system and is predicted to intercept our planet's orbit sometime this week, bringing with it the energy released by one of the most intense storms observed in recent years. Given the magnitude of the event, global monitoring agencies, such as the U.S. National Oceanic and Atmospheric Administration, NOAA, have issued specific warnings about the imminent impact of this stellar material. According to data released by the space weather platform spaceweather.com, the coronal mass ejection jet is expected to hit Earth on Thursday, the 5th. Although the main core of the explosion is not perfectly aligned with our planet, the debris cloud will pass, grazing the Earth's atmosphere. This tangential impact was enough to generate a G1 class geomagnetic storm warning. Although this category is considered weak on a scale that goes up to G5, the mere existence of the warning underlines the power of the original eruption, capable of disrupting Earth's magnetic environment even without a direct hit. To understand the gravity and nature of this phenomenon, it is essential to contextualize the functioning of our star, which operates in activity cycles of approximately 11 years. Currently, the Sun is going through the so-called solar cycle 25, a phase that has proven to be more intense than many initial predictions suggested. During the peak of these cycles, the solar surface is dotted with dark spots, which are nothing more than gigantic concentrations of magnetic energy. When the magnetic field lines in these sunspots become excessively entangled, they can rupture and reconnect explosively, acting like a stretched elastic band that finally snaps. This violent process generates solar wind bursts and coronal mass ejections, CMEs, launching radioactive particles out of the star and creating the conditions for the space weather we experience now. The classification of these explosions follows a rigorous system based on the intensity of the X-rays released at the moment of rupture. Scientists use a letter scale, A, B, C, M, and X, to categorize the strength of the event, where each level represents a tenfold increase in power compared to the previous one. Within this system, Class X represents the most intense flares possible, true solar cataclysms capable of causing radio blackouts and long-lasting radiation storms. In addition to the letter, a number accompanies the classification to refine the measurement of its strength. Therefore, an X2 eruption is twice as powerful as an X1, and so on. The recent X 8.1 magnitude event is therefore at the top of the stellar violence scale, explaining the concern and fascination it has generated in the scientific community. Although the coronal mass ejection was not launched on a head-on collision course with Earth, the grazing effect predicted for this week should not be underestimated. Due to the extreme force of the original explosion, classified as the third largest of the entire solar cycle 25, which began in December 2019, the disturbance in the Earth's magnetic field could be significant. If the G1 geomagnetic storm is confirmed, the most likely effects include slight fluctuations in electrical power distribution networks and occasional interference with the operations of satellites orbiting the planet. Furthermore, for observers located at high latitudes in the far north of the globe, there is the visual promise of the formation of auroras borealis, a luminous spectacle that occurs when solar particles interact with atmospheric gases. However, the situation demands caution and continuous monitoring, as the possibility of the phenomenon intensifying cannot be ruled out. The active region responsible for the eruption, sunspot AR4366, has demonstrated a surge of explosive productivity, generating multiple detonations in sequence. This behavior suggests that the interplanetary medium between the Sun and Earth may be charged with additional turbulence, which could enhance the interaction of solar material with our magnetosphere. Furthermore, the Sun's rotation, which completes a turn around its own axis every 27 days, plays a crucial role in the risk dynamics, as sunspots disappear and reappear periodically, altering their angle of attack relative to Earth. An aggravating factor for the coming days is precisely the Sun's rotational movement combined with Earth's revolution, which is positioning the colossal sunspot AR4366 directly in our line of sight. At the beginning of the week, this monstrous active region was located more laterally, but now it is turning to aim directly at our planet. This drastically alters the risk scenario. Any new coronal mass ejection triggered by subsequent explosions in this region will not just graze us, but will be launched directly in our direction. The orbital geometry has transformed what was a glancing blow into a cannon pointed at Earth, increasing the likelihood of more severe geomagnetic storms should the sunspot continue its frenetic activity. The magnitude of this eruption factory was captured in stunning detail by astrophotographer Eduardo Chaburger Popo, who photographed the Sun from Rafaela, Argentina. The image, obtained through a telescope specialized in H-alpha, reveals the sunspot AR4366 as a vast dark region in the upper left corner of the solar disk, possessing dimensions that exceed the size of Earth by more than 10 times. Popo described the moment as one of intense activity, noting that the sunspot produced dozens of M-class eruptions and 4 X-class eruptions in a period of just 24 hours. This instability is fueled by a delta-class magnetic field, a rare and dangerous configuration where opposing magnetic poles are dangerously close, creating an environment prone to massive magnetic short circuits and imminent new explosions. To finalize the analysis of the severity of this event, it is important to note where the X8.1 eruption fits on the podium of solar flares in this cycle. Although it was a super-powerful event that opened the month of February with a bang, it currently occupies the bronze medal, being the third largest explosion of solar cycle 25. Second place belongs to an X8.7 class explosion that occurred on May 12, 2024, originating from the AR3664 region. However, the absolute record to date remains with the impressive X9.1 eruption, produced on October 3rd of the same year by the sunspot AR3842. This ranking demonstrates that the Sun is in a phase of increasing violence, and with the AR4366 sunspot now facing Earth, the scientific community remains on alert, awaiting the next chapters of this cosmic spectacle of brute force.